This lecture is on using and applying lubricants and coolants. And we have three learning objectives: identify types of lubricants and coolants, use and apply lubricants and coolants, and perform housekeeping activities, of course, on lubricants and coolants. So what's the importance of lubricants and coolants? Here, they reduce friction and wear between moving parts. They help transfer heat and cool engine parts. They clean the inside of the engine by removing contaminants such as metal, dirt, plastic, rubber, and other particles. They cut power loss and increase fuel economy and absorb shocks between moving parts to quiet engine operative and increase engine life. So the lubrication system is extremely important to engine service life because it forces oil to high friction points in the engine. Without a lubrication system, friction parts between parts would destroy the engine very quickly. Many of the engine parts would rapidly overheat and score from this friction. So engine bearings, piston rings, walls, and other components could also be ruined. So this is the engine, and the red the arrows here is actually the movement of the oil inside the engine gallery. Okay, so we have here types of lubricants. The first one is the engine oil. So the engine oil is called motor oil, uh, is used to produce a lubricating film on the moving parts of an engine. It is commonly refined from crude oil or petroleum, which is extracted from deep within the earth. So synthetic oils or manufactured oils are also available. They can be made from substances other than crude oil. An oil film, the thin layer of oil, separates engine parts to prevent metal on metal contact. When selecting oil for an engine, it is important that the one chosen is suitable for the engine itself and the conditions under which it is to be used. So there are two important factors determining the choice of oils. That those are, first, the oil meets the quality requirements, and then the second one is the oil has the right thickness, or what we call the right viscosity. Okay. Next, the term viscosity refers to the relative thickness of the liquid. Gaano ka-thick ba siya? It's a thin, free-flowing liquid. Liquid has a low viscosity, and a thick, slow-flowing liquid has a high viscosity. Yung tubig, for example, that has a very, very low viscosity kasi mabilis yung pag-flow niya. Pag slow-flowing, okay, like that of other liquid materials, then they have a high viscosity. So the viscosity of a liquid changes when the temperature changes. At high temperature, the liquid oil for example, becomes thinner. So there would be a lower viscosity, and at low temperature, the liquid becomes thicker, therefore, coming up with a higher viscosity. The correct oil viscosity is essential for the efficient operation of the engine. Okay? Yes, it is very important because when the oil is too thick or the viscosity is very high, it causes resistance and much more power is needed to turn the engine, making it difficult to start when it is cold. Okay. For the motorists, they have experienced this one. And the thick oil does not circulate freely enough during the starting period, causing insufficient lubrication of the bearings and consequently increase wear, the wear and tear of the bearings. Oil which is too thin, on the other hand, combined with a high engine temperature and a heavy load, presents the risk of oil being pressed out from between the working surface of the bearings or the other parts. And this would cause the oil film, which is essential to the proper lubrication of the engine, to break down. Furthermore, between the piston rings and the cylinder. So, maraming masisira doon. This is most significant characteristic of lubricating with its viscosity. This can be measured in different ways. One way, for instance, is to check the quantity of oil which passes through the tube of standard size during a certain length of time and at a given temperature. So we have the powertrain and running gears oil. So most gear oil is a mineral oil refined from crude oil. So some gear oil is manufactured or synthetic oil. Chemical additives are mixed with gear oil to improve its load carrying capacity. This makes an extreme of heat on oil viscosity and foaming, corrosion, and oil sealing damage. So the gear oil used in many cars and trucks is relatively thick and has a viscosity ranging from psi 75W to psi 140. Multigrade gear oils such as psi 75W to 90 are also used. However, some manufacturers specify synchromesh transmission fluid, or they call it the STP, for manual transmission and transaxles. Now, what about the grease? So, the grease is a fluid sac of mineral oil made from petroleum. It's thickened with an agent that makes it semi-solid. So, the thickening agent, that is a metallic soap or non-soap substance such as clay, okay, to make it stick together. So, it's a fluid sac there from petroleum. uh, Good grease must have consistency, stability, oxidation, resistance, ability to protect against friction, wear and corrosion, and feed ability. This is ability to flow through dispensing equipment such as wheel bearing, universal joint, ball joint, and chassis fittings. So there are also different types of lubricants and coolants. We have the first one, the service ratings of oil. So oil is rated by viscosity number and also by its service designation. This is kind of service for which the oil is best suited. There are six service ratings for spark ignition engine lubricating oils. We have the SA, SB, SC, SD, and SF. There are four service ratings for compression ignition in engine lubricating oils. We have the CA, CB, CC, and CD. Let's try to look at the CA oil. So this oil is for utility gasoline and diesel engines operating under mild conditions. So protection by additives is not required, and this oil may have pour point and foam depressants. The SB oil, on the other hand, is for service in gasoline engines operated such as mild conditions that only minimum protection by additives required. SC oil is for service typical of gasoline engines in the 1964 to 1967 models of passenger cars and trucks. It is intended primarily for use in passenger cars. So this oil provides control of high and low temperature engine deposits, wear, rust, and corrosion. We also have the SD oil. This is for service typical of gasoline engine in passenger cars and trucks beginning with 1968 models. This oil provides more protection from high and low temperature engine deposits, wear, rust, and corrosion than SC does. Next, we also have the SE oil. It's for service typical of gasoline engines in passenger cars and some trucks beginning in 1972. This oil provides more protection against oil oxidation, high temperature engine deposits, rust, corrosion, and so do oils with the SC and the SC ratings. SF oil is for service typical for gasoline engines in passenger cars and some trucks beginning in 1981 models. This oil provides more protection than SE oils against sludge, varnish, wear, oil screening, plugging, and engine deposits. Notice that this is an open-end series. So when the car manufacturers and oil producers see the need for other types of oil, they can bring out the SG, SH, service rated oils, and so on. So SA and SB oils are not recommended for use in automobile engines. These are non-detergent oils. Detergent oils are required in modern automotive engines. So diesel engine oils must have different properties than oils for gasoline engines. The CA, CB, CC, and CD ratings indicate ample. CA oil is for light duty service. CD oil is for severe duty service, typical for turbo change, high output diesel engines operating on fuel with high sulfur content. Oil for use in automotive diesel engines should be marked SF or SC or SF or CD. SF or CC, I should say, or SF or CD. Okay. Now we have a wide range of oil viscosity from very thin oil. So SAE 5W up to thick Psi 50 oil. Every Psi grade represents an oil suitable for use within the special range of temperature and for certain types of engines, such as the following. The first one is oils within the viscosity grades of Psi 5W, 10W, and 20W are suitable for use in climates with temperatures ranging from very low to moderate. Okay. Psi 20 and Psi 30 are suitable for use in moderate to hot climates. Psi 40 and Psi 50 are mostly for use in cold engines designed for rather thick oil or in badly worn engines with high oil consumption. However, many engines are operated in climates where the temperature varies considerably from season to season, so there is a problem with that. In addition, it is always preferable for any engine to run on low viscosity oil during the starting period when the engine is cold, and on high viscosity oil when the engine is hot and fully loaded. For practical reason, it is not possible to use a low viscosity oil for starting and then change the oil to a higher viscosity when running. The use and application of lubricant and cooling. So here, use lift or floor jack and stands to raise a car in level position. Place the catch pan under the drain plug. Okay. Then unscrew the drain plug and allow oil to pour onto pan. Okay. You're trying to bleed. Next, use filter wrench to remove the old filter. Then turn counterclockwise. And then wipe clean oil or new filter O-ring. This will assure proper tightening. Then install and tighten all filter by hand. Hands and filter should be clean and dry. Use a rag if necessary. Then tighten the drain plug. Install correct type and quantity of oil. Pour oil filter or breather opening in the valve cover. Then safety measures in handling lubricants. So if they are not properly handled, they can become contaminated with dirt, water, and other fluids, reducing the service lives of the lubricant and the equipment and possibly causing equipment failure. So proper oil storage is the first step to preventing contamination. Okay, oil should be stored in closed containers that keep airborne particulates and moisture out. So according to Jim Morrison, a field technician with Petro-Canada America Lubricants, it can be costly mistake to store oil in open containers or allow drums to be partially open to air. Air is extremely dirty, therefore, you must never allow oil to get exposed to it, he said. Okay, then safety precautions in applying lubricants. So you have to wear your PPE, especially your eyewear. Oil and filter change require that the vehicle be safely raised and supported. Also, use caution around hot surfaces such as exhaust manifolds, pipes, and mufflers. Then always refer to the vehicle manufacturer's shop's manual for specific procedures. Okay, for housekeeping, it's very important for us to know the 5S. Okay, the 5S, it means sort, systematize, shine, standardize, and self-discipline. So this one came from Japan. It originated from Japan, and it's very important for us to practice. For environmental requirements, we have the segregation and secondary containment. So we have to segregate, separate acid chemicals from basic chemicals according to pH, then separate oxidizers from organic chemicals and inorganic reducing agents. Remember the fire triangle. Separate water reactive chemicals from aqueous solutions, then separate chemicals with multiple hazards from all other chemicals. That's all. Thank you and see you again next time.